Okay, so today I'm going to teach you how to draw a 4 by 1 multiplexer and the logic illustration behind it. So um, a multiplexer is a combinational circuit that selects one of several analog or digital input signals and forwards the selected input into a single output line. The selection is controlled by a set of select lines. A 4 by 1 multiplexer has 4 data inputs, 2 select lines, and 1 output. The inputs are data inputs, that's D0, D1, D2, and D3. The select lines are S0 and S1, and E is the enable, that's active, high, or low. So, without much talking, we'll dive into creating the 4 by 1 multiplexer. Okay, so we'll select the end gate. The end gate. So we are going to need 4 end gates. So let's take here, somewhere here, one, control C. We're going to need another one. We're going to need another gate somewhere, let's say here. Let's take another gate somewhere, okay, somewhere here. One, two, three, four. So another gate here. Wait, let's adjust this gate for. Oh, yeah, and this one too. Yeah, one. Okay, and let's get to the last gate somewhere here. Alright, yeah. So now we've got our 4 end gates. And the next one, it's okay. So let's adjust this one small. Yeah. So now we have our 4 end gates. We are going to need an OR gate. Okay. So we take this our OR gate, place it somewhere here that's suitable. Okay. So let's take somewhere here. Let's take. Yeah, let's take somewhere. So we now have our OR gate. Yeah, we now have our OR gate. Okay, so initially the outputs were 2. Yeah, so I changed the output to 4. Yeah, so now we are going to connect this line, sorry, this line to that of. I'm going to connect this to input 1. Here we go with the second one. Okay, all right. Yeah, then we go to the second input. Go third one. Uh, third one. Okay, go here. Go somewhere here. That's it. Then just left with the last line. Last line. We're going to take it from somewhere here. Yeah. So then here, go to this line from here we go to this. Yeah, so there. Wait, wait, hold up. Let's correct something here. So the alignment can a little bit can be a bit tricky. So let's go to this side. Sorry about that. Delete. Yeah, let's delete this one too. Delete section. Oh, sorry. Uh, you okay? Okay. So sorry for the mistake. So sorry. Okay. So I made a mistake here. So yeah, to this side. Yeah, that's it. Yeah. So that's it. So now we've connected our lines. We've connected our lines, right? Okay. Okay. So now we need to reduce the. Now we need to make the number of inputs for the out with the end gates three each. So all of them will get three each. Okay. So three. Three. So now we've made a number of input three. Okay. So we're also going to need a not gate. Yeah, a not gate. You're going to need two of the not gate. So let's give the not gate somewhere here. Sorry for that. Let's give the not gate somewhere here. Oh, oh, sorry. Somewhere here. And we're gonna get another not gate to here. Just below it. Okay. And now we are going to need a pin. And the pin is this. So that's the pin. You're going to need six, yeah, six of these. Okay, so now you are going to need four of the pins for to connect these lines. So you're going to need one here, one, connect this, connect this to this. You need another pin for this. You're going to connect it to this. Good. Going to connect another pin to this. So joining this to this. Yeah. See, we have proper connections here. So we're gonna get to the last one. That's over here. I'm going to connect this to it. Then now we have a connection. So we are also going to bring the outputs of this one to the OR gate, which is somewhere, should be somewhere here. Okay, so now let's connect this line to this, and we see we have a connection here. So we're also going to attach another two pins to the NOT gate. Yo, so now we are going to get two pins over here. Sorry for the inconvenience. Going to get two pins over here. Just two pins over here so that we can connect them to the NOT gate. So now we are going to join this together, and now we are going to connect the rest of the input gates to this. The NOT gates. So now you see we have a connection here. Yes, we have a connection over here. Yes, and we have a connection, so we are connected. And we're also going to connect the inputs of the top gate to these lines over here. So we have our first connection to the first NOT gate, and also this one. Sorry for to connect that to the second NOT gate. So we have a connection over here. Okay, so we're going to connect the second input of the second AND gate to this line. So you have a connection, and the last input to connect that to this line over here. So as you see, we have a connection right here. Okay, so we are going to have this gate, this inputs connecting to this line over here. Sorry, yeah. I'm going to have the last one of this connecting to, sorry for that. I'm going to have this connecting to that over here. So as you can see, we have a 0010. Yeah, so right now we are going to simulate it and see when we have a zero input what we get, when we have a one input what we get. So let's run a simulation and see. Okay, so now we are going to run a simulation. So here we can see the first one is not sending in data. Sorry for that. The second one is not sending any sort of data. Third one is not sending any sort of data. But you can see clearly the fourth one is going through. Yeah, it's sending data through to the output. So it means it's working. And so now when we this output, it's last and the second. We can now see the second one is sending data through to the output. So it means when you switch this one to 1 and 0, it means we what? We get an output. Yeah. Yeah, so it means it's working. And now let's make here 1 1 and here. Now you can see when we switch this one is actually sending data through to the output. So it means we made here 1 1 and made we added 1 1 to this thing. Switching both on, both turned on actually helps the first input to send data through to the output. So it means both are working. So now these are circuits. When you turn it on, it works. Off, it doesn't work. On, it works. So this is just the basic or the basic illustration behind a 4 by 1 multiplexer. Thank you. Okay, so we are going to move on to the 2 by 4 multiplexer. So I'll go ahead, create a new file and show you how it's done. So this is the basic structure of a 4 by 1 multiplexer. So before you simulate, you have to know where the select lines, which select lines you are to run and get a perfect output, and what to do and so on. So I'm going to also show you a 2 by 4 how a 2 by 4 multiplexer is used in um, um, the next design I'm going to do. So follow up and let's continue with that. Okay, so let's continue. Let's create a new setup. Yeah, we have a new setup. So for this one, we are going to need a decoder. Yeah, a decoder for that. So let's check for our decoder, right? Sorry, I'm check. Hold up. Okay, so let's dive into creating a 2 by 4 multiplexer. So we go here, we are going to get our decoder, and the decoder, we're going to input the decoder over here, somewhere here, and we are going to change the disable the enable, right? So no, and we're going to change the number of bits to 2, so 2, which will give you 4 inputs over here. So now we are going to need uh we are going to need so now we are going to need um we're going to need our outputs. That's this over here. So we're going to get 4 outputs. So get over here 1, yeah, and 2, third one, and a fourth, yeah, the fourth. Sorry. Yeah. Mm. Okay, so now we have our four outputs. So now we are going to connect them to the inputs of the decoder. So sorry. So let's go about that. Then connect to the first one, the second one, which also goes. Sorry. Then we go to the second one. The third one also goes through to uh, sorry. Delete that. So so since we want to make it straight, then for the last one, go to get the select lines over here. Select lines over here for this. So this is the structure of how the select lines are being connected to the inputs of the decoder and the outputs. So let's continue. Okay, so now we've connected the lines. You can see there's still one input over here because select bit is 2. So we are going to add our inputs. Let's take our inputs over here. Okay, so now we are going to extend the line from here to here. Then we have a line. But see, we have an incompatible width, so we're going to change the data bits from here from 1 to 2. See, and it works. Okay, so you see when we inputted 0 0, we have first logic gate, that's input of 1 to turn on. So now let's change this bit, one of the bits, to 1 1. Yeah, sure. Sorry about that. Hold on, I'm coming. Sorry, sorry. Okay. Um. Okay. So now we can see first our first logic gate is on. So now let's change this to 1. You can see the second one is turned on. Now let's change here to 1 0. You can see the third gate is turned on. And now let's change this to 1 1, and you can see our fourth gate is turned on. So everything runs perfectly with the perfect combination. So 0 0 turns on the first gate, 0 1 turns on the second gate, 1 0 turns on the third gate, and 1 1 turns on the fourth gate. So that's the basic illustration and structure behind a 2 by 4 multiplexer. Thank you very much.